Welcome to FactSpeak channel. Before to start on today's topic, please don't forget to subscribe, like and press notification bell button. Turkey and Syria are located on a complex plate boundary zone, where the Arabian Plate and the Eurasian Plate are colliding. This collision has resulted in the uplift of the region and the formation of several mountain ranges, including the Taurus and Zagros Mountains. Due to the collision, the region is prone to earthquakes, which can cause significant damage and loss of life. In particular, the eastern part of Turkey is particularly vulnerable to earthquakes, as it is located near the boundary between the two plates and has experienced several large and damaging earthquakes in recent history. In addition to the earthquakes caused by plate collision, the region is also subject to earthquakes caused by the movement of faults within the Earth's crust. The North Anatolian Fault, for example, is a major fault system that runs through Turkey and is responsible for several large and damaging earthquakes in the past century. To mitigate the risks associated with earthquakes in the region, it is important for Turkey and Syria to have strong building codes and emergency preparedness plans in place. This can help to reduce the risk of damage and loss of life from earthquakes and improve the resilience of communities in the face of seismic hazards. As a result of this collision, the region has a long history of earthquakes. Some notable earthquakes in Turkey and Syria include the August 1999 earthquake in Turkey, which had a magnitude of 7.4 and caused widespread damage in the northwestern part of the country. The November 2011 earthquake in eastern Turkey, which had a magnitude of 7.2 and caused widespread damage and fatalities. The collision between the Arabian Plate and the Eurasian Plate makes the region vulnerable to earthquakes, and seismic activity is likely to continue in the future. To reduce the risk of damage and loss of life from earthquakes, it's important for the region to have strong building codes and emergency preparedness plans in place. Plate tectonics theory. Plate tectonics is a scientific theory that explains how the Earth's lithosphere is divided into large plates that move and interact with each other. It was first proposed in the 1960s and has since become one of the most important and widely accepted theories in the field of Earth science. Plate tectonics helps us understand how the Earth's surface has changed over time and how geological events such as earthquakes, volcanic eruptions, and mountain building occur. The theory is based on several key observations and concepts, including the Earth's lithosphere is divided into plates. The plates move and interact with each other at plate boundaries. Plate boundaries are classified into three types: divergent, convergent, and transform. Earthquakes occur at plate boundaries, particularly at convergent and transform boundaries. Volcanic activity is often associated with plate boundaries, particularly at divergent and convergent boundaries. Plate tectonics is driven by heat transfer from the Earth's interior, which causes convection currents in the mantle and drives the movement of the plates. Plate tectonics has important implications for our understanding of the Earth's history and evolution. For example, plate tectonics can help us understand how continents have moved and collided with each other over millions of years, forming mountain ranges and shaping the geography of the Earth. It also helps us understand the distribution of earthquakes and volcanic eruptions around the world, and how they can impact human populations and infrastructure. One of the key pieces of evidence for plate tectonics is the distribution of earthquakes around the world. Earthquakes occur at plate boundaries, particularly at convergent and transform boundaries, where the plates are in contact with each other and can cause friction and stress. This stress can build up over time and result in sudden movement, releasing energy as an earthquake. Another important piece of evidence for plate tectonics is the distribution of volcanic activity around the world. Volcanic eruptions are often associated with plate boundaries, particularly at divergent and convergent boundaries. At divergent plate boundaries, magma rises from the mantle and solidifies, creating new oceanic crust. At convergent plate boundaries, one plate is forced beneath the other in a process called subduction, causing the magma to rise and resulting in volcanic activity. In addition to earthquakes and volcanic activity, plate tectonics also has important implications for the Earth's climate and the distribution of life. For example, plate tectonics can cause changes in ocean currents, which can affect global climate patterns. It can also cause land masses to move and collide with each other, affecting the distribution of flora and fauna and the evolution of species. Overall, plate tectonics is a complex and dynamic process that has shaped the Earth's surface and had a significant impact on its geological, climatic, and biological history. Understanding plate tectonics is an important aspect of Earth science and helps us better understand the processes that shape our planet and the geological events that occur on its surface. There are several tectonic plates on Earth, and their movements are responsible for most earthquakes and volcanic eruptions. The number of tectonic plates is estimated to be around 7 to 8 major plates and several minor plates. The 7 to 8 major plates are African Plate, Antarctic Plate, Australian Plate, Eurasian Plate, North American Plate, South American Plate, Pacific Plate, Indo-Australian Plate, also known as the Australian Plate. There are three types of plate boundaries: divergent, convergent, and transform. At divergent plate boundaries, the plates move away from each other, causing magma to rise from the mantle and solidify, creating new oceanic crust. At convergent plate boundaries, the plates collide with each other, causing one plate to be forced beneath the other in a process called subduction. This can result in the creation of mountains, earthquakes, and volcanic eruptions. At transform plate boundaries, the plates slide past each other, causing earthquakes. The San Andreas Fault in California is an example of a transform plate boundary. The movement of the tectonic plates is caused by convection currents in the mantle. These currents are driven by heat transfer from the Earth's interior to the surface. As the mantle cools, it becomes denser and sinks, and as it heats up, it rises, causing the plates to move. It's important to understand that the Earth's tectonic plates are constantly in motion and that the boundaries between the plates are active zones where earthquakes, volcanic eruptions, and the creation of new land masses can occur. Studying plate tectonics is an important aspect of Earth science and helps us better understand the processes that shape our planet. Let's delve into explanation of some of the key aspects of plate tectonics. Plate boundaries. There are three main types of plate boundaries: divergent, convergent, and transform. At divergent boundaries, two plates move away from each other, and magma rises to the surface to form new crust. At convergent boundaries, two plates collide and one plate is forced beneath the other in a process known as subduction. At transform boundaries, two plates slide past one another, creating a transform fault. Plate movements. The movement of the plates is driven by convection currents in the mantle, which is the semi-liquid layer below the Earth's crust. The convection currents can cause the plates to move apart, collide, or slide past one another, depending on the type of boundary. The speed at which the plates move is relatively slow, at a rate of a few centimeters per year, but over millions of years this movement can result in significant changes to the Earth's surface. Earthquakes. Plate tectonics is a major factor in the occurrence of earthquakes. Earthquakes occur at plate boundaries, and the largest earthquakes typically occur at convergent boundaries where two plates are colliding. At these boundaries, the movement of the plates creates tremendous stress that is released in the form of earthquakes. Volcanic eruptions. Volcanic eruptions are also closely linked to plate tectonics. At divergent boundaries, magma rises to the surface to form new crust. At convergent boundaries, magma rises from the mantle and is forced to the surface, resulting in volcanic activity. Some of the world's most active volcanic areas are located at plate boundaries, such as the Ring of Fire around the Pacific Ocean. Mountain building. Plate tectonics also plays a major role in the creation of mountain ranges. At convergent boundaries, two plates collide and one plate is forced beneath the other, leading to the creation of mountain ranges. For example, the Andes mountain range in South America was formed as the South American Plate collided with the Nazca Plate. Oceanic trenches. Plate tectonics also results in the creation of oceanic trenches, which are long, narrow valleys in the ocean floor. These trenches are formed at convergent boundaries where one plate is being subducted beneath the other. The Mariana Trench in the western Pacific Ocean is one of the deepest oceanic trenches on Earth. Overall, plate tectonics provides a comprehensive explanation for a range of geological phenomena and has revolutionized the study of geology. It provides a framework for understanding the dynamic processes that shape the Earth and is a key concept in the study of geology. Please don't forget to subscribe, like, press notification bell button and provide your feedback in comment section.